We will start in 2 minutes. I hope that everyone is able to hear me. Can you guys write in the chat once? Can you guys hear me? Just write it in the chat once whether you can hear me. Okay. Uh, so today's topic is templates and a bit about me. So I am Tushajan and I'm currently a coordinator in programming club. Uh, so uh, today's topic has been divided into 4 parts. The first part is part A, where we will be covering some basic things related to templates. Uh, then part B, which is types of templates. Part C, which contains some special things related to templates, and then part D, a bit about STL. So first, what is templates and what is the need of templates? So sometimes what happens is that when we are writing code for, let's say like we are writing a big code for some big project, and then we have to use a function multiple times for different kinds of data types. So we have to write a similar body for every function. And let's say we have to use this for 3 data types, for example, like here I have given the example of GCD function. So GCD is greatest common divisor. So we might need GCD function for long, which is int 64, normal int, which is int 32, and short int, which is int 16. So there are 3 types of like integers. So we might need GCD for all these 3 functions, all these 3 data types. And if we define them separately, then we might have to write a similar type of code 3 times, which is not very efficient, considering that in this particular case, we have to write it only 3 times. In some cases, we might have to write it probably 10 times or 12 times or even more. So this is where the need of templates come. We generally use templates to get a code and create it sort of like a snippet so that we can use it for any data types we want. So this is where the need of templates come into place. And the main use of the main advantage that we get after using templates is that we save a lot of time because we don't have to write same code again and again. And we also save memory because obviously writing lines of code takes memory, and we always like to save both time and memory. So this is the syntax of templates. Uh, so the keyword is template, then type name T. Uh, Here T represents a data type. So whenever we are calling any function or any class, then we specify what t we are referring to. This might be int or long or char. This can be anything, but while defining the function, we use type name t, and then this next t is the return value of function. This can be void, like I have specified t here, but this can be void, this can be int. So this does not depend on this t, like whatever data type with which we are calling the function, but this can be anything in general. Or if we want it to be the return type of what the arguments data type is, then we can obviously specify it with t. Then function name or class name, uh, code in class, and then arguments in function. So arguments in function are specified by tx and ty, or t var1 comma t var2, where t is the data type of the uh, uh, t is the data type of the variable that we are calling. So the keyword we use here is type name. uh, Earlier, class keyword was also used, and it is still usable. If we use it, there won't be any change, but it is preferred to use type name because it is the newer convention. Uh, and both of them work pretty similarly, except a few differences, but that doesn't matter for now. So working off templates. Templates are expanded in compiler time. So how templates work is that we have defined a function here, uh, and we are calling it with, let's say, int and char, for example. So what will happen is that when compiler will compile this whole code, it will create two copies of this function. Instead of storing it as a template, it will create two copies of this function: int function, int x int y, and char function, char x char y. So it will create these two functions, and then uh, we can do whatever we want. So if we, let's just specify int function two times, char function two times, and long function two times. So it will create total three copies of function, because we are using three distinct type of functions, one with data type int, one with data type char, and the other with data type long. So in that way, it creates the copy, and then after uh, the calling process happens, this becomes a basic case of function overloading. So when we put int arguments, it will obviously go to this function rather than going to this function. So all this happens in compiler time, and it is similar to how the macros are expanded, or some other things like hashtag define and all are expanded. So this is the attendance QR code. Uh, we can wait for 1 minute. Okay, so moving forward. Uh, so now we move on to part B of the session. So there are the templates can be of various types. So the first type is function templates. These are the templates that we use while defining a function, because we might need functions with different data types for different usage. So here I have defined a function. Again, template type name t is the normal syntax that we use, and after that t max function tx comma ty. So this basically returns the maximum of both the numbers or character, whatever I am passing. So like we can see the example here, max function 1 comma 2. So this returns 2, max function a comma b, and this returns b. So this can be used for sort, min, max, and this is used in a lot of predefined C++ functions as well. The next type of templates are class templates. These are probably more important templates than function templates, because whenever we are defining a class, we might need to use a data type multiple places. and it is not feasible to again replace the whole class code with a new class code with using different data types. So class templates are probably more important than function templates. So uh, here, I have just implemented DFS, depth first search, which is a common concept uh, using templates. So the code doesn't matter here, but what matters is the syntax that I have used. So let's say here I have used template uh, type name T class graph, and I have some stuff in private and some functions in public. Now in private also, whenever I have defined, let's say this, I have defined this as this map. So we have T here as well as T here and T here. So this is again the same data type that we are using. And also in the functions, I have defined TX, TY, and TX. So this is again the same data type that we are following when we defined a class. So this is how my class is defined. Now, after defining the class, I have to also define the functions in the class. While defining the functions in a class, we have to use the same type of syntax that we have used while defining function templates. So if we go back, what we do in function templates is template type name T and then defining a function. So in this also, we have to use template type name T. Then we have to specify the return type. Then we have to also specify that this function is a part of a class and not a separate function. So that's why we have used this. And after that, we have to specify the function. Uh, and then we have to write our code inside it. So I've done this for add edge function, DFS, and also initialize function. So in all the functions, I've followed the same type of syntax which I followed while defining function templates, which is important. And then we have to call it in main. So when we call in main, we have to specify the data type with which we are initializing our class. So here it was type name T, but while initializing here, we have to specify that, okay, we are initializing it with int because we are going to create a class in which we need everything to be in int. We can also put this at as char, as long, uh, according to our need. The third type of templates are variable templates. So these are used to create parameterized variables. This feature is after C++ 14. Uh, so what the use of variable templates is if we need a particular constant, but in different data types everywhere. So let's say we are creating a code where we need to use the value of pi, and let's say it is a mathematical code. So somewhere we need the pi to have only one significant digit. Uh, in some other case, we need pi to have, let's say, 7 or 8 significant digits. So if we were to do it without templates, then what we would do is create a pi 1 variable which has only one significant digit, a pi 8 variable which has 8 significant digits, which is not very feasible. So what we can do is use templates, and then we can uh, like uh, use the we can specify the data type, and then we can this is similar to typecasting, but this is not exactly typecasting, but this is very similar to typecasting. So we can obviously change the value of the constant that we have provided according to the data type. So I have int here, so this particular thing gets converted only into 3. Then float. So if I print it as float, it prints till some 5 digits, basically 6 significant figures. And then if I set the precision to 10, and then I specify pi as double, then it prints till 10 decimal places. So, and the syntax for this is template parameters variable declaration. So this is a bit different from the other templates. Also, we might not use const expression here. I just used it because I am defining pi as a constant, but we might not, we might skip this whole thing, expression. Uh, the next is arguments deduction. So uh, argument deduction comes in the part C of the session. So what the new type of templates in C++, what they have added is it can automatically identify the type of the function, like the type of the data type we are using without specifying it. So if I move to previous slide, let's say here, yeah. So here I have specified int while calling a function, right? But what happens is that in arguments deduction, we don't need to specify int or double or anything like that. We can directly give the argument and it will automatically identify the data type for us. So I've passed 1.1 into the function. So it prints 1.1, which is obviously the first line. And then the second line is type ID x dot name. So this basically prints, tells us about the data type. So since I've passed 1.1, it takes it as a double and prints double. 1, it takes 1 as an integer and it prints I here. So we don't need to specify data type every time, which is actually very beneficial for us. The next thing is template specialization. So uh, what template specialization helps us is, let's say we are writing a template for some particular we are writing template for a particular code, and we need that code for every data type except some selected 1 or 2 data types, because we might have some better approach to solve that particular thing which we were expecting from the function, or we might need to compute something entirely differently for those particular data types, or our code might give some error if we use it for that particular data type. So we might need to use it. We might need to specify a different function for some particular data type. So this is where template specialization comes into place. So for template, first we specify the template, which is the normal syntax. So we specify the template here, and then we write template, and then we specify it for the particular data type that we want it. We want a different function. So I defined it separately for char. So if I use it for 1, it will print hello. If I use it for a, it will print by. Now, this can be helpful in some of the cases, and I have specified the case in the next slide. So let's say I'm writing a template to sort the array. So this is printing the sort. So again, template array and int size, which represents the size of the array. Now, I've used the normal sort function here. So the thing with the normal sort function is that it is n log n, which is good for most cases. But let's say I'm doing it for character. So for character, there is a better approach, which is on, using counting sort, which is better than n log n, and it is in it. Its time complexity is on. So I might use this thing over this thing for characters to make my code more efficient. So I've just I have just written a different code for character data type, and I'm using counting sort instead of the normal n log n sort. Both of them give the same result, but it is better to do counting sort for characters. And it is only possible for characters, and it is counting sort in general is not possible for integers. So this is how template specialization can be useful. So the next is variadic templates. So where sometimes what we need is templates in which we can have multiple arguments, and we might not know how many arguments we need to give before while writing the function. It depends on the use case. So in those cases, we use variadic templates. So variadic templates help us to give uh, 0 arguments, 1 argument, 2 arguments, or any number of arguments. So the way we define variadic templates is different from all the previous methods. So how we define, so first skip this part. I will come to this part later. First, let's look at this part, template, type name T, which is the normal thing. Then type name, these 3 dots and types. So what this means is that type name t means the uh, type of the first variable, first argument that we are passing into the function, and then type name triple dot and types. This is sort of writing all the other arguments as a single thing. Now, in the function, what we have written is t var1 and types triple dot var2. Now the difference is that we can access var1 because var1 is a defined thing. It is the first argument of the function, but we cannot access var2 because there might be one var2, there might be multiple var2s. So while using the function, we can only access var1 and not var2. Similarly, we can also write function t var1, t var2, and then types triple dot var3. We can also write function like that so that we can access the starting two variables and not the third variable onwards. So, so in this, what I'm doing is printing the variable, and then I'm passing the function with the argument var2. So now what it does is it goes through the function as a loop. Now, let's say I have one here. Let's say there is only one here. Okay. So func1, and then this part is empty. This part is empty. So it prints one, and then func, and then this particular part is empty here. Now, while defining this template, I haven't considered the case of defining a function with no arguments. So if I compile the code without defining this stop function, it will throw me an error. So that's why, just to get with that edge case, so I defined this function with zero arguments. So what happens is that it prints one and then passes no arguments into this function again. And instead of going to this template, because obviously this template accounts for only more one or more arguments, it goes through this function and then prints the end. So we get the output one the end. For 1 comma c, what happens is that this is 1, and then we have c here as variable 2. So it prints 1, passes c as c in the function. Then it again goes through this template again. Function c and then no argument here. Then function no argument here, and it again goes to here. So 1, c, and the end. If we have 1, c, and 3.14, now see, the data types of all these three are different, right? But still it prints 1, c, 3.14, and the end because we are using a template, and with each iteration we are passing a variable which might be of different data type. So the next types, these types uh, might not depend on t. Fine. So like the types might be different from t. So let's say I'm passing 1c 3.14. So it's 1c and 3.14 here. Now c and 3.14 are taken together, and we print 1. We can access only the first argument here. Then we can pass c comma 3.14 here. Then c comma 3.14 goes here. Now we can access only c, and 3.14 is present here. Then we print c, and now we can do only 3.14. Now 3.14 is present here, and we have nothing here. So we print 3.14, and then we pass no argument into the function, and we print the end. So we can also, if we don't want to print the end, we can also like print only the new line character or just nothing. So that will also work, but I just defined the end here to specify the need of defining a function with no arguments. So this is the basic syntax of it. Template, type name t, type name triple dot types. Now these triple dots are important. You cannot specify 2 dots or 4 dots. Like 3 dots are important here. This is a part of the syntax. T function, t var1, and types triple dot var2. So uh, so now comes the part D of the session. Uh, the actual use of templates is like there is a standard use of templates in standard template library, which we use a lot in competitive programming, as well as in dev. So standard template library is a set of C++ template classes to provide common programming data structures and functions such as list, stacks, arrays, etc. And it contains classes, algorithms, and iterators So the benefit of STL is that we don't have to write uh, a code again and again, and it gives us some good data structures with some good optimizations that we can use to our advantage. So STL has four main containers, four main components: algorithms, containers, functions, and iterators. So you can read more about STL from Geeks for Geeks. Also, we had a session in Adapt regarding STL. So, and there is one more important thing about using keyword in STL. This is a special keyword which is present in STL. So, uh, using keyword can be used to specify a single namespace or multiple namespaces. So, you have seen a lot of times, like in the code using namespace std. So it just specifies a container. Uh, a container like namespace is not exactly a container, but std is sort of a namespace. So we can use using to call this. Using can also be used for inheritance, for aliasing, like using f is equal to first. And then we can also use using for directives, like using stdcout. And you can read more about using keyword from Geek for Geeks. So yeah, that's it for this session. And you can scan the QR code for attendance and do give us the feedback so that we can improve in further sessions. And you can ask any doubts you have in the chat. In set precision, 10, it has 9. Okay, yeah. So set precision means the number of significant digits. So that's why it has 9 decimal, because 3 is also a significant digit. That's why. What is aliasing and another term? So uh, like aliasing is, let's say when we are calling the first thing from a pair. So we sometimes write like using f is equal to first to make our job simpler, to make our code, you can say, contain less text so that we have to type less. So we use something like using f is equal to first, and using using for directives. So using stdcout so that we don't have to write stdcout again and again. So it is there. So yeah, you can read about it more from Geeks or Geeks also. They have covered it in much detail. So you guys can ask any other doubts you have in the chat. Okay. So are there any other doubts? What is the main use of templates? So like I mentioned it in the slides, that we don't have to write the code again and again. Like Okay, so like here you can see that writing the code for GCD. So let's say you are writing a code for code of GCD and for int. Okay, so you have written GCD int x comma int y. Now you cannot pass long x and long y into that particular function, because if you try to do that, like while compiling, it will give error that the data types don't match. But it's good that we define only GCD one time, and we are able to use it for all types of int, whether it is unsigned, not unsigned, long, int, short, whatever type of int, whatever type of number we have. It will be good if we can use GCD for all those data types. So instead of defining templates for 3 times, 4 times, 6 times, whatever times, you need to define it only once using templates, and then you can use it for all the types of numbers you have. So this is like one of the basic needs, one of the basic use of templates. The other use you can get, like I showed in the class templates. So like I defined a template for implementing DFS. Now, for this case, my graph had integer nodes. What if my graph had character nodes, like the nodes were A, B, C, D? Or what if there were so many nodes that integer could not store it? There were more than 10 raised to 10 nodes. Then obviously it would be better to have like also have long, right? So that is the main use of templates. Like we don't need to define everything again and again, because defining this long of a code again and again will take too much space and too much time. When will we get the homework for this? So the main homework for the whole CodeCraft is a project that you will get attendance link. Okay. Okay. Counting sort for characters. Okay. Okay. So for the characters, what I have done is I have created a vector, a frequency vector. So like in this case, I have implemented it only for small case characters. So I've created a vector of size 26. And then for each character, what I have done is I've incremented array I minus 97 by 1. So for A, like the ASCII of A is 97. So frequency 0 will get incremented by 1. Similarly, for B, frequency of 1 will get incremented by 1. So sort of like this. And then what I did was, since I know that there are only 26 characters, so what I can do is I can iterate through all the elements of array, store the frequency of each element, and then what I can do is print how many times A is occurring, uh, like whatever times, and then how many times B is occurring. So I went through all the elements, then I got the frequency of them, and for I is equal to 0 to I less than 26, that means going through all the elements of frequency array, I am printing A whatever times frequency 0 is coming. That means that many times A was present in the initial array. So this is ON approach. This does not require ON and login. So that's why counting sort is better. But the reason why we don't use counting sort in things like int or long is because we don't know what is the limit of our numbers in that particular array. We might have number from 0 to 10 raised to 18. Now we can't create a frequency array of length 10 raised to 18. Like it won't be possible. So it's only possible when we know the starting point and ending point of a particular like array. We know the minimum and maximum, and also minimum and maximum don't have that big of a difference, so that we can implement frequency array and it is feasible. So that is how counting sort works. As the topic for the project being released here. I don't think the topic is released yet. I'm not sure, but if it is not released, then it will be released in a few days. Any other doubts? Yes, you can leave. Okay, if, there, uh, if the doubts are clear, then